No. Okay. So, um, this is the last thing, and it's a little weird, but the math part is extremely easy. Everything that you have to do for these problems is in the plan. The plan is obnoxious. Everything else is really simple. Okay, so just from everything you know from the semester, if you have a confidence interval, how are you going to start it? How does a confidence interval start in every single situation? Beautiful. Okay, blank percent confidence interval 4. Okay, now what are some things that we have in the past put here? Not for this lesson, you don't know what goes there yet, but for P equals the true proportion, for mu equals the true mean. Okay, so for this, it's beta, which is capital Greek letter beta, equals the slope of the true regression line relating y equals to x equals. Okay, what does this have to do with? This has to do with chapter 3. There's going to be a lot of chapter 3 review, which is great because I'm pretty sure you forgot it all and you need to review it. One of the things you really need to review is binomial and geometric, and another thing is scatter plots. So here we go, reviewing. Okay. So can you guys all get out your packet and find the page that says 12.3a, 12.3b example? Okay, guys, in a few minutes, we're going to do a confidence interval for this situation. What I want to do real quick is just verbally put the state, just say the state out loud, looking at this scatter plot. Okay, so we're going to do a 95% confidence interval for our example. 95% confidence interval for B equals the slope of the true regression line relating yield per plant in kilograms to fertilizer in grams. Okay, Y to X. Everybody got it? Yeah, you have to. You have to. So there's going to be the thing about this particular thing is this part's annoying. The math is super simple. Okay, now this is where the most annoying part comes in. So just get mentally prepared to be irritated. Okay, T interval for slope. There are 5 conditions for an interval or a test for slope. That is probably the worst thing I'm going to say today. I just got it over with. I'm excited. Okay. And there's a way to remember them, and the word is liner. So it goes like this. We'll put it over to the side. Liner. Okay. And this is what you'll use to help you remember the conditions. Now you'll know them, most of them, 3 of them, you'll know, but we could actually make a pretty good guess on some of them, what they stand for. L in this case stands for linear. Okay. So to satisfy the linear condition, you check the scatter plot for a linear pattern, or big or the residual plot for no curved pattern. Okay, does anybody remember what a residual plot is? Okay, so this guy here, this is pretty terrible, but it doesn't look like a curve. It's enough. This guy here, what you're looking for is it for not to be like a curve like this or something like that. So the residual plot, if you remember, is the scatter plot turned 45 degrees basically, and then zoomed in. So these are the same dots as these. It's just that you turn it and zoom in. And on the residual plot, it's much easier to see a curved shape. I don't see anything here. It looks good. Okay. I. What do you guys think I stands for? Hmm? Someone can tell me. Independent. Okay. And what is the condition that we always use? What do we do for the independent? All the other things. 10%. This is going to be exactly how you write the 10% condition in all of your other FRQs. Nothing new. N equals whatever is less than 10% of the population. Okay, what do you think the N is? Normality. Great. Okay, now in the normal condition, we usually check it, we call it large counts. Large counts and normal is the same thing. And in this case, you need to check the histogram they give you. And this is kind of like when you guys did the t-test, when you had the box plot and you were like, no extreme skew or outliers, that sort of thing. Or the problem says something like, previous research indicates that there's a normal population, blah, blah, something like that. We've dealt with that before. Okay, E is the one I would not expect you to get. This is equal standard deviation. Check the residual plot for even scatter around y equals 0. I hope it's occurring to you how much they're actually going to have to give you to do an FRQ on this. So they have to give you a lot of things, which is great. Okay, now what do I mean by these words? Check residual plot for even scatter around y equals 0. Okay, what I'm thinking here is that I draw lines like this, and there's not a pattern. Like they're not getting more spread out as they go. It's even, it's the same distance away here as it is here. Do you guys remember when I showed you that? Oh, you don't remember. It was like September. I showed you the one that was fluted. Anybody remember a fluted residual plot? Let me get a post-it note. Do you remember me saying the word? No, it's September. Mrs. Talbot, what do you expect from us? I also lost my post-it notes. It's fine. It's totally okay. They're here somewhere. My desk is, anyway. Okay. So I don't even know what's happening. Oh, I have extra paper in here. Look at my tiny notebook. So cute. Okay. So when I say violating the condition for a residual plot, it would be something like this. Where on this side, the residuals were really small, and on this side, the residuals are big. So this would violate the equal SD condition. So you want them to be like same distance at the front as they are in the back. This one's not perfect, by the way, and none of these are. So you gotta kind of, assume. Okay, last one. You know what the R stands for? Random. Nope. Um, it does not. I just came up, well, I think the book came up with this word liner to help you remember the five things, but I don't care what order they're in. Yes, correct. Same thing. Mm-hmm. And we'll put ourselves a little note. Okay, there are formulas. They are on your sheet. And it looks like this. So statistic plus or it's supposed to be plus or minus. Oh goodness. Oh goodness. I need the white out. Okay. So we're here down in this box. So statistic plus or minus critical value is T. For these are all T. There's no Z in any of this. It's all T. And the formula is, which one do I want to use here? This. Okay. However, you're never going to do this. So just trust me. Trusting. Okay. All of these problems, not only are they going to give you all those graphs, they're actually going to give you computer output. They're going to give you this. That's why I said that the do step is extremely simple. There's no math really. You just need to know which things go in which spots, which we're going to review. Okay, so this is the slope. The whole problem, by the way, if you can keep in mind that this whole problem is about slope, it really helps. This is going to be from the computer output. I have to be honest, I have never seen an FRQ where they didn't give you the computer output. Now, um, last year's kids told me this was one of the FRQs of the 6 on the AP exam. I find that hard to believe. I have not printed it out yet, but we'll see. So, okay, now let's just review T star. Inverse T, parentheses 1 minus percent divided by 2 degrees of freedom. And then the last thing you need to know is what is degrees of freedom for this stuff? Okay. And degrees of freedom is different. It's n minus 2. Okay. Why is it minus 2? It's 1 for the x coordinate and 1 for the y coordinate because these are two variable things. So you have to take off. You can't control the last x and you can't control the last y. Oh, that should say, I don't know what I'm doing. You need a lot of stuff to be able to do this problem. So instead of having you cut and paste something into a notebook, I just made it a whole resource page. So almost everything that we need is on the resource page. So when you're done setting this part up, grab that because we're going to that next. We don't have it. That's good. There's nothing. Oh, wait a minute. Okay. All right. Once you're situated, grab the resource page and we'll read it together. The research group for Sunbucks wanted to conduct another smaller study on the effects of a new organic fertilizer on the total mass of coffee beans produced per plant. The company obtains a random sample of 33 coffee plants. I'm going to highlight that. Oh, who stole my highlighter? Mr. Guinan came in and took my highlighter. Mr. Guinan's been upset about someone stealing his highlighter for days. You can ask him. He took mine. That's fine. We're good. Forgot. I gave it to him. Okay. 33 coffee plants, random sample. We know we need that. 33 coffee plants. And grows them in a controlled environment similar to the actual growth environment. The company uses a completely randomized design, randomly assigning. Look, there's random sample and random assignment. I think we should just to cover ourselves. Randomly assigning 3 plants to receive a level of organic fertilizer between 0 and 40 grams in increments of 4. The mass of coffee produced by each plant during its growing season is recorded. Ironically, the supervisor for Sunbuck spilled coffee on the computer in the research lab, destroying the computer. Wow, I'm so sorry. If this sounds like CPM to you, that's because it is. It was not a complete loss since there had been a paper report created. The following graphs and calculations survived, although there's a significant coffee stain on the regression output table. Okay, they did that on purpose because they wanted you to actually think. Okay. All right, so let's go through this and remember some of the things from chapter 3, and then we'll go back to the sentence part. So we're going to use this for the linear condition. The scatter plot, the original scatter plot will be used for the linear condition. The residual plot can be used for the linear condition. And the equal standard deviation condition. Okay, so you might be thinking to yourself, could they get away with just giving me a residual plot? Yes. Okay, now scroll down a bit. What condition do you think that this is for? Normal. Okay. Now, this is the part where we need to review everything we learned from chapter 3. Oh, your faith. Okay. So, the equation is y hat equals a plus bx. B is the slope. The word that has constant next to it, that's a, because it's a constant. Do you see how a is a constant here in the equation? Do you know what I mean by constant? Okay. And b is right below it. So a is the top line B is the bottom line. This is the standard error of the slope. That is the number that you will put in the parentheses after T star. This is the standard deviation of the residuals. It's just S. I don't really know why I just labeled it S again, but that's okay. Okay, and then the last thing I want to mention is that R squared is literally R squared. So R is the square root of that. Here's another thing I can't explain. R squared, the coefficient of determination is capital R and lowercase r. The correlation coefficient is I don't know why they went to capital. Oh, that's going to be my answer from now on for my whole life. Okay, so we're going to go with 0.313. Okay. All right, now we're back to the notebook. So this is all we needed to write on here. Not too bad. Now we're going to go back to the notebook and see if you remember any of the interpretation sentences from chapter 3. You're like, I can guarantee you, Mrs. Talbot, I do not. Okay. Let's start with an easy one. A. What is the number for A from your resource page? 0.85. Okay, and what is that thing? The constant, the y-intercept. Okay, so at 0 grams of fertilizer, we predict 0.85 kilograms yield per plant of coffee beans. At 0x, we predict A of y. Let me say that again. At 0 of x, we predict A of y. Okay, which thing is B? 0.0173. What thing is this? Slope. For every increase in 1 gram of fertilizer, we predict. Okay, what goes next? You guys can tell me. Okay, don't forget an increase. Because remember, it's slope of 0.0173 watts. Kilograms. For every increase in 1x, we predict a either increase or decrease depending on the sign of the slope of slope y. Okay, what is S from the other page? Okay, does anybody remember what S is from chapter 3? A standard deviation of the residuals. Okay, meaning how the distance from the residuals, the length of the residuals, basically. Okay. The actual 684. I did it. I did it wrong? 0. That's a really different number than the one I did. This is the thing I screwed up, so I want to make sure I do it right. I screwed this up last week. Now I'm checking third, fourth, guessing myself. Do you see how this opens out a little bit in the other books? That's because I had it out earlier, because I wanted to check myself. I want to check myself again. It's just because I care about you. Okay. Okay. You can see now why I wanted to check. Okay, so the actual is the dot on the scatter plot. And it's saying typically are that far away from the regression line, so that's the length of the residual. If you're using fertilizer as your experiment. So do you guys remember how we drew in all the residuals? We like took a line and drew them all in. If I averaged the length of those, it would be 0.6841. Okay, the really important thing here that I try to remember for myself is it's talking about y the whole time until it says x equals fertilizer. So the actual y typically varies from the estimated y using x. So y, all this stuff is y until the very end. Okay, more, and then we're done with this, and then we're just gonna do that FRQ and we're done. Okay, and I believe this one is new, this guy. Okay, now tell me if I'm wrong. This number is 0.0094, correct? Okay,
No,
when did I hit pause? No one would do that. You think I hit it when I went to get the book? I have no idea. Yeah, I did hit it at the beginning though, right? Yeah, I did. Okay, I would say that we have 10 minutes left and then we're done. Not too bad. What? Yes. Okay, when you're ready, try the state yourself. Give it a go. You got this. Okay, when you're ready, check mine. If you put x equals and y equals, it doesn't matter. It doesn't have to be, you'll read them almost always with y first, but if you put x first, it's not wrong. Any questions about the state? Yeah.
Says like freshman line relating amount of fertilizer, will it always put the X first? Like when it's reading the problem out? Like,
No, you have to look at the graph. So they switch it up, unfortunately. So you have to come over here and go, oh, fertilizers X, yield per plants Y. They have to give you so many things that like, anyway. Okay. T interval for slope. Okay, you don't have to space it the same way as me. I just looked at how I wrote it last year. Okay. So looking at this, I don't know, it looks terrible, but whatever. And does it jive with this, like weak, right?
yeah.
Yeah, so we're not really that shocked, but I don't see a curve, so. Okay, now you don't have to write both of those things, but since it's note, I just wanted to make sure that you had, yeah,
Always gonna be
yeah,
like,
you have to keep going. Even if it looks like this is terrible. I couldn't have picked a worse one, really. It looks awful,
you still say that.
but we go on. The show must go on. Yeah, okay. Independent, n equals what? 33? I just threw on that little bonus.
So we don't have to do 10% on the random assignment.
Correct. This one had both a random sample and random assignment though, so I felt like I needed to cover myself.
But if it has both, you don't have to, even if it's sample and assignment.
I would do both. I would do it. Why not?
Both.
Yeah, like if you're taking the AP exam and you're not sure, it's, yeah, because it's literally writing like 6 words. You could get a 4 instead of a 5, like you don't know. Okay. Normal, I forgot to write independent, didn't I? I believe I've also seen these with a box plot or a stem and leaf plot. Just the same as all of the T ones, you're just looking for extreme skew or outliers. Yay. Okay, so the first thing after the 75,492 conditions, a lot of these, by the way, the ones I have seen, from the College Board say assume conditions have been met. When you see that, you should throw a little bit of invisible confetti in the air, because that means that you can skip this whole part. You like this, you go like this. Yeah. Okay. T star equals inverse T 1 minus 0.95 over 2. What's the degrees of freedom in this problem? 31. Remember, it's n minus 2. New thing for today. Okay, make yourself do it with the parentheses and everything. We're so close. And always positive, just like the other ones, 2.04. Okay, so it goes B plus or minus T star times the standard error of the slope. B was something. 0.0173. Standard error of the slope was 0.0094. Which will come out to negative 0.00192. 0.0365. You guys all know how I did that? I multiplied these and then I did the plus and the minus. Okay. Okay, that is the end of the writing. I just want to ask one more question. What if I were to ask you if there is convincing evidence that there was an association between fertilizer and yield for plants? So like underneath this, I would say, I don't know, something like B, which I didn't write, but let's pretend there's B. Does your interval provide convincing evidence of an association between yield per plant and fertilizer?
No,
No, why not?
zero's an interval.
Correct. Zero is an interval, which means that zero is a possibility for the slope, which means you do not have convincing evidence of a relationship, association, whatever. This is exactly the same thing as we learned before. Just, we're looking for zero in that slope. So think of something with a zero slope will be flat, which would be really close to no association. Now, wait, before we're done, real quick. Does that jive with this graph? Yes, this graph is terrible. It's all over the place. So I'm not surprised at all that zero was in the interval because I don't really see a really great association there. Okay, do you see how that all ties together? So you can actually check your conclusion back with this, be like, oh, that makes sense. Okay, now